domain and range. We want to quickly look at this topic today, and let's pay attention because I'll be giving you some tips that will make what we have on the pages in the portal to make a lot of sense to you. Now, when we say domain is simply the value that must be substituted in a function that makes it defined. Domain represent the values to be substituted in a function that makes it defined. Okay. For a polynomial, for any polynomial, as we have on the screen right now, the domain is usually minus infinity to positive infinity, negative infinity to positive infinity. It means I can substitute any real value. I can substitute any value into a polynomial and it's going to be defined. It's going to be what? Defined. So any value at all, if I substitute minus 10, minus 1 million, minus 100, minus 1,000, if I substitute positive 1,000, positive 1 million, all of them will give me a particular value. Good. So that's what we mean by the domain. What are the values such that, in a simple language, such that when you substitute it in that function, we give you a particular value, or we make it to be defined. Good. So this is an example of functions that we can call, say they are polynomials. Though the first example that is showing us there is a linear function, which can still be called a polynomial. Okay, then the other one is a quadratic function. We have x squared plus 3x minus 4. So for these values, the domain will basically be negative infinity to infinity. Now let's look at domain of a rational functions. Domain of a rational function. Let's look at this as a model example. You have the question on the screen. We want to find the domain of the function, this rational function we have on the screen. Let's look at the solution. The solution is what we show next now. What we are going to do is pick the denominator of that function. Now if I solve that function with an equal to 0, okay, we have an equation. The answer I'm going to get makes that to be undefined. Look at the denominator. The value we are solving here now is the only value that will make that function to be undefined, and which is minus 5 over 2. So just solve 2x plus 5 is not equal to 0. So when we solve it, we have x is not equal to minus 5 over 2. It means it is only minus 5 over 2 that is not part of the domain, or is not a value in the domain of that f of x. Every other thing forms part of the domain. Okay, because you try to substitute minus 5 over 2 in that denominator of that function, you see that, and you press your calculator, it's going to give us undefined because the value makes the denominator to be 0. Whenever you divide anything by 0, it's going to give us undefined. So it's not part of the domain. Okay, so let's see what we have next. Look at the way we have written our domain now. It means x is an element of R. R represents real numbers. X is not minus 5 over 2. That means it can take any other value apart from minus 5 over 2. So this represents our domain using set notation. We can also write it this way, an interval notation. That means since we have every other thing apart from minus 5 over 2, we have from minus infinity down to minus 5 over 2 union that same minus 5 over 2 down to infinity. So we can also write it like this. So we use that minus 5 over 2 in our interval notation. So these are the ways we can represent our domain. We can write it in set notation or interval notation. Good. Now, this is another similar example of rational function that I want to show you that we can solve exactly the way I have explained this model example now. We say find the domain of f of x equals to what we have on the screen. All you need to do, just solve that denominator. Say is not equal to 0. Solve the quadratic equation that we have there, or the quadratic expression. Factorize the quadratic expression. So the two factors you have will be the only values that will not be part of the domain of that function. Okay, so this is another rational function that is staring you in the face. All you need to do is solve the denominator, and you are going to have two values that will make that function to be undefined. It's only those two values that will not be part of the domain. Every other value, real value, forms the domain. Good. So let's see the domain of square root function. The domain of square root function. Okay. Let's look at another model example. And this is the question we have for this. We have this function as you can see on the screen. Now, if we have this function, let's look at the solution. The function is defined whenever what we have in that square root is greater than or equal to 0. As you know, we cannot have a negative value inside the square root or within the square root. It's going to make it a complex number, so it makes it undefined. So we solve, when you have a square root function, solve whatever you have within the square root. Make it greater or equal to 0. That's all. So when I solve this simple inequality now, I'm going to have x is greater than or equal to 7 over 3. Okay, x will be greater than or equal to 7 over 3. So is either from equal to 7 over 3 or greater than that value. So it means the domain of that function are all real values of x greater than or equal to 7 over 3. We have found the domain. So that means domain can be any value that is greater than or equal to 7 over 3. It means 7 over 3 is part of our domain, and any value that is greater than that. Because those are the values that will substitute in that function that will not make it to be negative. Any value you will substitute in that function, this square root function, that will give you negative is not part of the domain. Okay, so that is the concept for this. Good. Now let's write the set notation. The set notation, we can say x is an element of R such that x is greater than or equal to 7 over 3. That's the mathematical implication, or how to write it in set notation. X is an element of R, or real numbers. R represents real numbers, such that the dot dot means such that x is greater than or equal to 7 over 3. Writing it in interval notation, that we have written it, that means 7 over 3 to infinity. Any value from 7 over 3 down to infinity. Okay, those are the values. If you substitute any of this value in that square root function, is going to be what? Defined. So domain is simply whatever you substitute into a function that makes it defined. If there's anything you are substituting there that makes it undefined, will not be part of the domain. I believe you have really learned something from today's class. Thank you for your attention.